Hello. So we are back on our first lesson, yeah? This is the beginning of the school, so we'll start with just a little bit of theory, yeah? Not too much, just exactly what we need. Okay? Before we start, if you are here watching this video, probably you want to learn electronics. And you know you are on the right video, because the electronic probably is the future. And learning electronics, from my point, nothing can go wrong. So you are in good hands. Good. If you are scared, it's normal. Obviously, you know nothing about this. If you know, probably it's boring. If you don't know, don't be scared. I know it's scary. It's scary on the beginning, I know that. But it's scary on same way people were scared by fire or lightning, before. But soon as they know how they work, so same with electronics, soon as you will know the basic, the foundation, yeah? Because I will say the Ohm law is the foundation of the electronics. So everything what is electronic is built with the Ohm law foundation, yeah? Good. Let's draw a circuit, yeah? And I'll start with a wire. With a simple wire. That's a wire. Okay, wire. The electric current on any circuit is driven by conductivity. Yeah? And conductivity can be different. So we mostly use copper wires. Compare with the aluminum wires. Aluminum I think is half. So the aluminum can carry like half of the energy. Half of the electric current. Silver, it's even better than copper, but it's more expensive. So we have a wire, and the electricity, the electric current, is going through this wire like a stream, like a flux. Yeah. We can make to compare the electric current exactly like using a gun. So the size of the bullet is the current, the amps, and the speed is the voltage. And here current and voltage is a very strong relationship. Next one, I will draw a resistor. A resistor is creating resistance, yeah? Resistor. Resistance is the opposite of the conductivity, yeah? So compare with the conductivity, resistance is resisting against the electric current. Same way like a bad guy, he's resisting. The resistor, usually we name the resistor like R. And the symbol is ohm. And I will draw now a power supply, because we have a power supply here. That's symbol for the power supply with plus and minus. Also the power supply can be a battery. On this case the symbol will be like that, plus and minus. So we have a circuit. A circuit is a loop. Okay, so in our case this is the loop. How the current is flowing from plus to minus. Yeah. That's the most easy way to understand the circuit. Yeah, actually the things are a little bit different, and actually the current is flow from minus to plus, but it's hard to work with on this way with a circuit. So let's say like Anyone is working with the current flowing from plus to minus. So we have a power supply, we have a resistor, and we have wires. Now we need to find some values there, yeah? On our case, we have our power supply. You can see the meter on the corner, 12 volts. So we have 12 volts, and we have our electric bulb, classic one. When we are applying the electricity on the bulb will light up. Now it's on. Okay? So what do we know? We know we have 12 volts. We need to know the current. The current is 1.6 amps. It is 1.6. So we know the current, 1.6. 1.6 I. The current is I. The voltage is V, and the resistor is R, yeah? So we know the current. We have to find, let's say, the resistance of the resistor. Resistance of the resistor, I'll draw a triangle because that's the more easy things to apply the Ohm law. Volts on the top, I and R. Divide, here is times. So in our case, we don't know the resistance. We want to know the resistance. So the resistance will be, we don't know the resistance, yeah? V, the voltage, divide by current, and we'll find the resistance. Voltage is 12, divide by 1.6, 7.5. So our resistor, 7.5 ohms. Okay? Easy. If you don't know the voltage, I 1.6 times 7.5, which is the resistor. Or if we don't know the current, 12 volts, 12 divide by 7.5, and you'll get the current. Okay? That's basic. It's nothing hard. Okay? Now, the electric current can be DC or AC. The direct current, which is just a line, like ours, we have plus and minus, or AC. AC is something like that. On AC, the plus and minus from our power supply get changed, depends how many hertz. It's the frequency on your country. On Europe is 50 hertz. So 50 hertz, that means 50 times per second. The plus will get changed with minus. Plus get changed with minus, and waveform will go to 0, yeah? So it will go to 0 and go on the other side, yeah? So that's the AC. AC, it's used on your mains. So we have AC there. We have 220 AC. Why it's AC and not DC? Because the AC compared with the direct current, AC is a little bit less dangerous. Yeah. On DC, if you get electrocuted, yeah, there's no way to take your hand out. On AC, you have 50 times per second chance to get your hands out, yeah? But it's not only about that. AC it's used because it's very easy to be managed. So with AC, you can come with like they use on the high voltage to transport the current, yeah? So you can come with AC straight on the transformer and transform the current from a value to another value. It's so easy. On DC you can't do something like that. To convert DC is more hard, yeah? That's the main reason probably why is AC it's used. Yeah, so that's it with AC. One more problem with the AC, yeah? On AC, yeah, it's that's why the AC it's used. But AC cannot be carried like high energy on the cables. On the AC you have you'll learn this when you go and when we will study about the high frequency currents. On the high frequency AC, yeah, you have what is called skin effect. So you cannot carry too much current on the cables. So actually on 50 Hertz, I think you have around 1 centimeter. That's the cable what you can use. If you use a larger cable, actually you carry nothing. So every one has plus and minus, DC and AC. Yeah, the minus on the AC is all the electronics, not all, most of them, they use DC. So everything is working with DC. So on some point from the main you have to change AC on DC. Okay? Now going back on the Ohm law. Why this is important? Because everything on this world, what it's electronic, any device, they have a power supply. The circuit itself is a resistor, yeah. So actually the laptop is a resistor, and we have a current. And this is very probably you'll not use this formula, the Ohm law, but you have to know what's going on there. Because I have, like, at work, yeah, just like I want to give you an example. We have so many people coming buying chargers, and I try to give them chargers. I try to give them better chargers. So you see laptop charger 19 volts, 3.3 amps, and I try to give them 4.7 amps. Obviously are better. But they say no, that will burn my laptop. But they don't know the Ohm law. So you understand how these things works. So the current is made by the resistance. So obviously if here I will have 100 amps power supply, nothing will get changed. That's clear, yeah? Because we have this formula. And the current is given us by the resistance. So yeah, that's what I'm trying to do at work. I'm trying to give them 4.7 amps because obviously high amperage is mean the charger will work cooler and will last longer. But they say, actually the manufacturer didn't fit the 4.7 because, they try to keep the cost low. But using high amperage power supply, using like more than you need. So the laptop need 2 amps, or let's use a 4 amps charger. That's a lot better because the charger will work cooler, or the power supply will be cooler. Like my power supply is a 15 amps power supply. If I'm using 1 amp, the power supply, or 5 amps, everything is cool here. But soon as I will use like 10 amps, 12 amps, it will get very hot. That's the explanation. Okay? Now, what we can speak more about one of the Kirchhoff law. Actually, when you have two resistors, yeah, let's connect a second resistor. You'll have two currents. One is going here, I will say this I1, and one is going here, and I will say I2. And the total current, I total, is I1 plus I2. That's again very important. So if you connect a different resistance, let's try and do it here. Maybe I can because I have two bulbs. Let's say we have 12 volts there. So we have a bulb and I have the second one. But I don't know how I'll connect the second one. What about screwdriver? Screwdriver, yeah, it's a conductor? Yeah, it is, it's metal. Let's try and do something like that. You just keep an eye on the ammeter, yeah? Check the current, it's 3.3 amps. You can see? 3.3 amps. So actually the current flow, yeah, this one is given us by the resistance and obviously the power supply. Let's say a case, we have 12 volts. Let's get the amps out, yeah? So I'll go with the amps out. Now we have no amps, we have 12 volts. Actually it is a little bit of current there, but 12 volts, yeah, let's say no amps. Or maybe 100 milliamps, doesn't matter. I just took out the current just to see what happened. So if I try to light up the bulb, no light, and the voltage drop. You can see? So that's what happens when you don't have enough current. The voltage goes away, like on our case. Okay? What I can say on real life, the things are not exactly like in paper. Like on our case we have this resistance. Okay, let's speak about the circuit losses. You know that conservation law, so actually nothing get lost here. Everything, all this current going from the resistor which resists against the current, everything get changed in heat. Yeah, that's very important. That's another aspect because electronics and heat is not a good idea. Heat. How much heat? Heat is I times voltage equals watts. Yeah. So in our case we have, let me check, 12 volts times and 1.6 amp, 1.6 amp, 19.2 watts. Yeah, 19.2 watts. Yeah, that's very, very important. The heat is not good on electronics. Also, these wires, coming back on the real life examples, these wires, they have their own resistance. Yeah. So this schematics, it's just on a like superconductivity. Superconductivity That means circuit with 0 ohms. Okay? Well, of course, superconductivity it's around minus, if I remember, minus 273 degrees Celsius, and I think never been reached by humanity. So that's zero absolute, yeah, superconductivity. But in real life, on the wires, you have resistance, and obviously, if you have a resistance, you have heat. Yeah, more of that. Yeah, apart from the heat and resistance on the wires, you have a magnetic field, which is something else. But probably we'll speak this on a different lesson. Okay, I think that's all for today. And yeah, that's the first lesson. I'm not good on these things, on teaching. I like to fix things. I will try to just make you understand how these things works. Because finish with the theory, yeah, I finish, yeah. Not really, it's more theory, but we'll go on with lessons, with the next lessons. We'll start speaking about the components, and after that, you know, we'll apply some of this formula, we'll build some things. But that's the beginning, that's only the beginning. Yeah? So thank you for watching. Like and subscribe if you like the video, and see you on the next lessons. Thank you, bye.